Hello and welcome to another fun-filled adventure in Math with Mr. Sims. Today we're going to be doing our review for our test number 17, or cycle 17 test. It's actually test 1 and 2. It's going to be showing up for your enjoyment this Tuesday, I believe. Pardon me. So anyway, what we're going to do today is we're going to once again run through problems just like we always do. Make sure you have a piece of paper handy, that you're following along with all the problems, that you're working through the problems with me. Once again, this is the very least you should do. You should also be doing the study sheets so that you're really just getting those skills in place for yourself. But once again, this is a really good place to start because it's like having Mr. Sims tutor you and help you study for the test. So a really good thing to do is actually run through the problems and then maybe try and run through the problems again just to make sure you got it. But without further ado, I'm going to go ahead and get started so that we're not taking too much of your time here. Once again, I'm going to run through as many problems as I can in about 30 minutes. So Alexa, your turn to keep me honest. Alexa, set a timer for 30 minutes. And off we go. Alright, so the first question is identify the vertex in the following, and it gives you this equation here, which is y is equal to negative 4 times x minus 3 squared plus 7. And if you're looking at that, you might be wondering, okay, well, what parts are the vertex? So let's look at this real quick. If you look at the vertex form of an equation, you have y is equal to a, right, which is a constant, times x minus h, right, squared plus k. Okay, sorry about that extra line there. Let me get rid of that. So this is the form for the vertex form, right? This is basically the form for it. And what you have is you have a constant that's being multiplied times this perfect square here, right? And then here I have a k and here I have an h, right? Now, when you're looking at this one here, what you have to be careful of is right here. The form itself, the formula itself has a negative. So whatever you see in here with this x, you have to actually take the opposite of it. So whatever's inside, you take the opposite of it, because once again, this negative sign belongs to the form, not the h, right? So in this case, I take the opposite of the negative 3. So the x value for my vertex is going to be this h comma k. That's going to be the point of the vertex, right? H comma k. And so I'm going to take that h here of it's going to be the opposite of negative 3. It's going to be 3, right? And the k value is going to be the same as what's on the end here. So on the end I have a 7, so I'm just going to make it 7. Okay, so once again, just to recap, what we saw is the form itself has a negative sign here. So because the form has a negative sign there, this negative actually belongs to the form, not the h, right? So my h value is going to be the opposite of this negative 3, which is a positive 3, okay? So just remember this. Whatever's in with the x, you take the opposite of it. That becomes your first number. Whatever's outside here is the 7. It becomes your second number, so the h comma k. So 3, 7 is my answer. All right, next one. Identify the vertex in the following. So once again, we have another one like this. You know what? I'm going to change this one just slightly so we see what would happen if it was positive. So if this one was positive instead, just pretend this whole thing had this positive here. In that case here, this would be my h, and this would be my k. And I would have to ask the question, well, if there's supposed to be a negative sign here, but I see a positive sign, then h had to have been negative, right? Because if you minus a negative 5, that would give you this plus 5 here, right? So once again, I would take the opposite of what I see here. It would be negative 5, comma 1. And once again, that's only because I changed the problem. I decided to change the problem so that we could see one that was positive here, okay? So that would be negative 5, 1 for the vertex there, okay? So anyway, all right, that's our first two problems down. Let's go. Rocking on. Here we go. Solve by factoring. 6x squared minus 5x minus 6. So to factor, I'm going to make my x, right? And once I make my x, I like to draw another x over here where I can give myself a little more room, right? On the top, I have a times c. On the bottom, I have b, right? My a times c is 6 times a negative 6, which is going to be a negative 36. My b is negative 5. And so I'm looking for two numbers that multiply to get negative 36, but add to get negative 5. And what I'm going to write out here is the factors of 36, but I'm going to remember that one of them has to be negative. Because if one of them's not negative, I'm not going to get this negative 36 that I need, okay? So 1 times 36 would give me 36, but there's no way one of those could be negative and add up to negative 5. So 2 times 18 would give me 36, but once again, if I add both of those, I'm not getting negative 5, right? So 3 times 12 Once again, if one of those is negative, not getting negative 5. 4 times 9. Ooh. If one of these is negative, it will add up to negative 5. So I have to ask myself the question, which one has to be negative to get the negative 5? And the answer is, has to be a negative 9. And just to check myself, 4 plus a negative 9 is equal to negative 5, which is what I needed here, so that is correct. Alright, so now I know my two numbers are going to be 4 and negative 9. Alright, so I put my 4 here, I put my negative 9 here, right? Sorry, let me try that again. Negative 9, right? And I'm going to take and bring down 6x squared plus 4x, right? That's from here. The negative 9 minus 9x, right? And then minus 6 is equal to 0, okay? I have the equal 0 here, right? So then I'm going to take and I'm going to group and factor out. So I group, and the biggest thing I can take out of here, it looks like, is 2x, right? So I'm going to divide both of these by 2x, right? So 2x comes out front, and I get 3x plus 2. Okay, now I want to once again get 3x plus 2 on this side, so I have to ask myself the question, what do I have to take out to get 3x plus 2? And I have to divide by a negative 3, because I need this negative to become a positive, right? So I pull out the negative 3 now, and I'm left sorry, with 3x plus 2. So because these 3x plus 2's are the same, the insides become one factor, and my outsides become another factor. All right. And that right there is not my answer, because they want me to solve it by factoring, not just factor it. I did factor it, but they want me to solve it. So now, pardon me, now that I have that, what I have to do is I have to set both of these equal to 0. So I'm going to start by basically splitting up my two equations, right? I'm going to have 2x minus 3 is equal to 0. And I'm going to have 3x plus 2 is equal to 0. This 2x minus 3, I'm going to add 3 to both sides. And I should get 2x equals 3. Divide by 2, divide by 2, and I get x is equal to 3 halves. Okay. And what I just did was I just found one answer to what x value will make this whole equation basically have a 0, or I'll explain that in just a second. Actually, let me go ahead and do this one. Subtract 2 from both sides. These cancel out. I get 3x is equal to negative 2. Divide by 3. Divide by 3. And I get x is equal to negative 2/3. Now, what I've just found with these two answers here is I found the place where both where if I plug in this x value, my quadratic is going to cross the x-axis at that point. So right here at 3 halves, it would cross here, and at negative 2/3, it would cross like right here. So my quadratic might be like this, something like this, where it goes through those points, right? You get the idea. Anyway, but that's what the whole point of us solving that was, so that we could actually see where it crosses the quadratic there. You don't need to particularly, well, hopefully you know that by now. But anyway, that was the answer that they're looking for, is 3 halves and negative 2/3. All right, let's go ahead and move forward. So what is the equation of the quadratic function shown in the graph? So for this one, they've given me a graph, and I need to make an equation for a quadratic function, right? So the way I'm going to do this is I'm going to start off by figuring out a couple important things. I like to start off by figuring out my zeros. So you'll figure out your zeros first, and our zeros are negative 1 and 3. So these are my two zeros, negative 1 and 3. Well, remember, your factors have to be the opposites of your zeros. So if my 0 is negative 1 and 3, then my factor has to be x plus 1 and x minus 3. Once again, the opposites of these. And the reason that's the case is when I plug this in, it needs to become 0. The whole thing does. So negative 1, if I plug in negative 1 plus 1 equals 0. 0 times whatever this is 0, right? So that makes it 0. Because what we're saying is when x is negative 1, the y value has to be 0. So that's why this factor has to be the opposite of this. Because when I plug it in, it has to make my y value 0, okay? And likewise with the 3. 3 minus 3 is 0. 0 times whatever this is 0. So that's going to work as well, okay? So anyway, so now you have your factors, right? And your factors are a really good start, but I have to take now and put them in to just kind of a basic equation for a quadratic here, where I have a times x plus 1 times x minus 3. And at this point, I'm almost done. Once again, my x and y's are free so that I can put in numbers and get the outcomes out, right? But this a is a constant that I need to solve for. I need to figure out what is this a value, right? I don't know that. So in order to do that, I have to plug in a value for x and y. And so what I'm going to do is I'm going to look at my graph and find an x and y value that I want to use. There's actually a lot I could use here. I could use negative 2, 5. I could use 3, 0. I could use 4, 5. I could use a ton of these, right? But one of the best ones for me to use is right here on your y-intercept. And the reason why is because at the y-intercept, x is 0, so a lot of this becomes a lot easier to work with, okay? So if you ever have a chance to use, if they give you your y-intercept, you definitely want to use that. If they don't give you your y-intercept, you just figure out whatever point you have, right? You're going to have an x and y point, right? And whatever point that is, that's the one you're going to use. So in this case, my x and y is going to be 0, comma, negative 3. Okay? So since that's my y-intercept, I'm going to go ahead and plug the negative 3 in for y, right? I just plugged it in. Is equal to a. I still don't know my a, but I'm going to solve it. X is going to be 0. And what we're saying is when x is 0, y is negative 3, right? So that's why we're plugging these in like we're doing. 0 minus 3, because once again there's another x, so that's also going to be 0, right? So now I just simplify it. Negative 3 is equal to a times 1 times a negative 3. And now that's equal to a times negative 3. Negative 3 is equal to that, right? Divide by negative 3 on both sides. And I should get a is equal to 1. And that right there is my final answer. No, I'm sorry, that's not my final answer. That's my a value. I need to go and plug that in right here. So my final answer is y is equal to 1 times x plus 1 times x minus 3. Okay. So in this one, actually, it's just y is equal to x plus 1 times x minus 3. I don't even need that 1 in this case. A lot of times your a will not be 1, so we just kind of lucked out that that was the case in this one. All right, let's move on. So once again, just to reiterate the steps before we move on, I found my zeros first, right? Once I found my zeros, I made my factors, which were the opposite of the zeros, right? Then I plug it into this basic equation of y is equal to a times the x plus 1 times the x minus 3, right? My two factors. And then I just plugged in an x and y value, any x and y value for my graph. I plugged it in, and I solved for a. And once I got a, I plug it back into this equation to get the final equation, okay? So my answer in this case is this. Really, I could have stopped here. This would have worked as well, okay? So let's continue. Ooh, next slide. Zoom out. Zoom in. I like it. All right, so let's do solve by completing the square. Let's talk about what that is. So if you're completing the square, what you're trying to do by completing the square is, once again, you're solving for roots, just like we've been doing, but we're doing a slightly different way, and it's actually a lot of fun. So the way that you do it by completing the square is this. First of all, I need to make this space right here open. Your A, B, and C, right? This C space needs to be open. The way I do that is I add 8 to both sides. So when I add 8 to both sides, I get x squared minus 4x, right, is equal to 8. Now, as you see, I have this nice spot open here, so I can turn this into a perfect square. And the way I turn it into a perfect square is this. I'm going to take this b value here. My b value is negative 4, okay? I'm going to take that b value, and I'm going to divide that negative 4 by 2. And I'm going to get a number. The number I get is negative 2. And it's very important. This number is going to be used, okay? It's not going to be used immediately, but it's going to be used. So I need to remember that number. And then this negative 2, I'm going to square this negative 2. Now, whenever you square a number, always put it in parentheses in your calculator, especially if it's a negative number, okay? So negative 2 squared is equal to a positive 4. So this 4 here I'm going to use right away. And the way I'm going to do that is I'm going to plug it in to both sides of this equation. It's going to fill in this gap right here. All right, so this is going to be plus 4 and plus 4. So I have x squared. Oh, actually, I'm not going to write that. I'm just going to copy this down. 8 plus 4 is 12, okay? Now, all of this, the whole reason for doing all of this right here, the whole reason for adding this 4 was so that I could turn this into a perfect square. It's the perfect square that makes it now is going to use this number right here. So what I'm going to do is I'm going to write my x, right? I'm going to have this squared. And this negative 2 is what goes in here with the x. So it's x minus 2 squared is equal to 12. Okay? So once again, the whole reason we did this whole process over here was to make this a perfect square by adding that 4 so that we could get this, right? And if you ever want to make sure you got that right, you can actually take and FOIL this out and see if you get this. And I'll do that for you real quick. If I take x minus 2, let me do that over here, sorry. If I do it over, let me do it over here. X minus 2, right? Times x minus 2. I get x squared minus 2x, right? Minus 2x, right? Plus 4. So I have x squared minus 2x minus 2x plus 4. That right there, when I add it all together, is x squared minus 4x plus 4, which is exactly what I had right here. And that's why you can do this jump here from here to here. You can do this jump because this is exactly the same thing as this right here, okay? And so one of the reasons why we made that 4, once again, we did this whole process, was because now this can become this. So anyway, after you do that, you get x minus 2 squared is equal to 12, right? And then you have to take and square root both sides. Okay? So that gives me x minus 2 is equal to these plus or minus square root of 12. All right. Now, unfortunately, I'm going to have to simplify that a little bit. It's not a big deal, right? But let me go ahead and add 2 to both sides. I'm sorry. Add 2 to this side. Add 2 to this side, so I should get x is equal to 2 plus or minus the square root of 12. And this right here is actually almost my final answer, but it's not. I don't know why I'm circling that. I got to simplify the square root of 12. So really this x is equal to 2 plus or minus the square root of 4 times the square root of 3, right? Because I need to simplify that whenever you have a radical. If you can't simplify, you need to. And that becomes x is equal to 2 plus or minus 2 square roots of 3. And that right there is, in fact, my final answer. That's the best that I can do, okay? So, all right. So hopefully that's made sense. Once again, just to review the steps, you start by making space by moving that 8 over, right? Once you do that, you get... once you do that, you open up that space, so then you can take this b value, divide it by 2, you get the negative 2. You take that negative 2, you square it, you get 4. You put that 4 in here, and now that becomes a perfect square of x minus 2 squared to make that, right? Then I take the square root of both sides, and, you know, the rest is history. All right. Hopefully this is making sense and you're feeling confident. Once again, you want to work that until you have it straight, okay? Don't just look at it, see me do it, and then assume that you have it, because you probably don't. You need just practice to make those work, okay? So let's convert from vertex form to standard form for this problem here. So in this problem, what they have is they've given us it in vertex form. That's that form that says y is equal to a, this is your a value, times x minus h squared plus k. And just as a reminder, this a being a negative a here, it tells me that it's going to open down, because a negative a is negative, like a sad face, right? So if it had been positive, it would open the other way. But anyway, that's not important. I just wanted to, while we're here, you know. So anyway, convert from vertex form to standard form. So to get from vertex form to standard form, what we're going to do is we're going to basically expand this as best I can, because to get to standard form, what they're looking for is y is equal to ax squared plus bx plus c. That's what they're looking for, okay? And so I need to get this to that, and the way I do that is by just basically expanding everything, okay? So I get f of x is equal to negative 2 times x minus 4 squared is really x minus 4 times x minus 4, then minus 7. So I need to start by foiling this out. So I get is equal to negative 2 times x squared, right? Minus 4x, right? Minus another 4x, right? Plus, I'm sorry, that's the minus, plus 16. Okay? And then all of that minus 7, okay? Now at this point, I'm going to simplify or combine like terms. I get negative 2 times x squared minus 8x, right? Plus 16. Do be careful with your parentheses here so that you don't make any mistakes trying to combine things that you shouldn't just yet, because this all has to be done first, right? Now I have my negative 2. I can distribute in that negative 2, right? I don't want to subtract 7 yet because multiplication comes before subtraction here. So I'm going to distribute in that negative 2, right? And I get, whoops, I get negative 2x squared, right? Negative 2x squared plus 16x, right? Plus 32 minus 7, okay? And this 32 minus 7 there is going to become 25. So that's going to become negative 2x squared plus 16x plus 25. And that right there is my answer in standard form. Oh, almost. F of x or y, which is the same thing, okay? So this right here is my answer in standard form, okay? All right, moving on. Here we go. A given parabola has its vertex at 2, 5, and it goes through the point 3, 7. What is the equation of the parabola in vertex form? Woo-wee. Okay, so a given parabola has its vertex at this, so it gives me the vertex and it gives me a point. So this is going to be my x and y value, right, that I'm going to use because it's a random point. And this right here is going to be my h, k. All right, remember your h and k are really an x and y value, but they're a very specific x and y value, which is why we label them h and k, because that's your vertex. So I'm going to go ahead and write down the form for vertex form, right? And if you're struggling remembering the form for vertex form, my suggestion is make sure you're looking carefully at your star chart, because all of these are in your star chart. All these equations are. There's actually not that much you have to memorize in terms of equations in Algebra 1, which is good. So you have your form here, a times x minus h squared. I always suggest to you, whenever you're doing a problem, always write out the formula. It does two things. It helps you commit to memory, and the other thing it does is it helps you to have a framework with which to work, right? You can keep referring back to it. If you do not write out your formula, you will get more problems wrong. You'll probably get, I don't know, for some people as many as half of the problems wrong, right? So make sure that you are writing down your formula. All right, so now that I have my formula there, I'm going to just start plugging in the things I have. The first thing I want to plug in is my hk. So I get y is equal to a times x minus my h, which is 2, right? Squared plus k. Oh, I'm sorry. My k is, whoops, that's not the right button. Plus my k, which is 5. Okay? So this is the beginning of me making my equation of the parabola in vertex form, okay? What I want to do now is I want to figure out this a. Unfortunately, I don't have an a value. They didn't give me that, but they did give me an x and y. So what I can do is I can plug in one x value and one y value, right? And then solve for a, because I know that this this point is on that parabola, right? So I'm going to go ahead and put that y, that 7 in for y, is a. I still don't know my a yet. I'm going to take the x. The x is 3 minus 2 squared plus 5. And now all I have to do is solve for a. So 3 minus 2, so a, this becomes, sorry, 7 is equal to a times, what's 3 minus 2? 3 minus 2 is 1. 1 squared plus 5, which is really just a is 1, a times 1 plus 5, right? Which is really just a plus 5 is equal to 7, right? So then I subtract 5 from both sides, and I should get a is equal to 2. So this is my a value, okay? Now that's not my answer, but that is my a value because they want the full equation. I need to take that 2 for a, and I'm going to plug it into this spot where I was missing my a value, right there. So now my answer is y is equal to 2 times x minus 2 squared plus 5. And once again, we leave, that is so ugly. Sorry, let me rewrite that, or that's going to bother me. All right. So y is equal to a times x. Oh, sorry, not a. It's 2. 2, because I found my a. 2 times x minus 2 squared plus 5. And what I want you to notice is that this is the right answer, by the way. But aside from it being the right answer, we left the x and the y's open, right? Because you do so that you can plug in values for x and still get values for y, right? So that's why you leave it open, because that's what makes it a function. You can, or one of the things that makes it a function, you can plug in values for x and get values of y out. All right, moving on, we have another problem. Let's see, solve by factoring. Oh yeah, we're gonna like this. All right, so this one we're gonna solve by factoring. We're gonna use for this one the x method, right? So I'm going to go ahead and take my x. Actually, I'm going to use my half x method because it has a coefficient of 1. That's going to make this a little bit faster for me, right? So once again, I'm going to make my little x on this side. And on the top, I have a times c. This is my a value, my b value, and my c value. If you don't have a value in front of your v squared term or your x squared or whatever, if there's no value, then the value is technically 1, okay? So this is 1 times a negative 5, which is negative 5, and the b value is negative 4. So I'm looking for two numbers that multiply to give me negative 5, but add to give me negative 4. So I'm going to go over here and write my factors of negative 5. My factors of negative 5 could be 1 and 5. In fact, that's all they can be, but one of those has to be negative to make this a negative 5. So it's going to probably be, if it wants to add up to get negative 4, it's going to be 1 plus a negative 5. In other words, I need two numbers to multiply to get negative 5. That's either 1 times negative 5 or negative 1 times 5, right? Well, negative 1, if I add negative 1 and 5, I don't get negative 4. If I add 1 and negative 5, I do get negative 4. So that's the one I want. 1 plus a negative 5 equals a negative 4, okay? So since that works, this is the one I want. So I pick my 1, I take my negative 5 here. I put those on the side, and I like to copy those over here too. 1 and negative 5. Now, because this is the half x method, don't forget there's a shortcut now I can move straight from here to my final answer, where I have v plus this one here, 1, and I have v minus 5, okay? And that right there is my final answer. Now, if you ever want to know if you got that right, by the way, one of the things you can do is you can actually factor this out to check yourself, right? So in this case, if I were to factor it out, I get v squared, right? Minus 5v, right? Plus 1v, right? Minus 5. I add this together, I get v squared minus 4v minus 5. And as you can see, that definitely worked, right? All right. All right, and so I have the factors now, v plus 1 and v minus 5. All right, so I have the v plus 1 and v minus 5 here, and what I'm going to do is I need to set those both equal to 0. So let me go ahead and erase some stuff here. Oh, I didn't want to do that. All right, let me go ahead and do that real quick. Get rid of some of that. All right, so I'm going to take that v plus 1 and v minus 5. I'm going to set them both equal to 0, okay? Whoops. So I have v plus 1, right? I'm going to set this equal to 0, okay? And I'm going to split this here, and I'm going to set, sorry, I have a couple spots here that are going to bother me. There we go. And this one I'm going to set v minus 5 equals 0 as well. So once again, once I have my two factors, I set them both equal to 0, right? Because all of this here has to be equal to 0 if we want to find the zeros, right? Or the solutions. So v plus 1 equals 0. I'm going to subtract 1. I get v is equal to negative 1. And this one I'm going to add 5, and I'm going to add 5, and I get v is equal to 5. And that right there, those right there are my solutions. And once again, with solutions, you put them in braces like this, and you put the least to your greatest. So negative 1 to 5, okay? And there we go. We got that. So let's see here. Okay. All right. All right, here's what I'm going to do. I'm going to try and do an axis of symmetry one just to make sure you have it for your test, and I think we're going to call it good. We already did one for completing the square. I wanted to do one more, but I think in the interest of time, we'll just do the axis of symmetry ones, all right? And then we'll call it good. But that's definitely a good one you want to work out because you want to make sure you're really good at completing the square, all right? So anyway, here we go. Find the axis symmetry of the following quadratic function here. Negative 4x squared minus 80x minus 22. Oh, by the way, I forgot to tell you what to draw. So everyone, right now on the top of your paper, go ahead and draw. So go ahead and write Cycle 17, test incentive video, right? Make sure in the upper right-hand corner you write your teacher's name, right? Make sure you write your name. Make sure you write your period, things like that. In the upper left-hand corner, I want you to draw a... I want you to draw a tardigrade. A tardigrade, okay? So a tardigrade, T-A-R-D-I-G-R-A-D-E. So you got to find out what a tardigrade is, and you got to draw it there, okay? So good luck. All right, so here we go. All right, so find the axis of symmetry of the following quadratic function here. So you got 4x, negative 4x squared minus 80x minus 22. So the axis of symmetry has an equation for it. X is equal to negative b over 2a. This is my axis of symmetry, okay? And that axis of symmetry has never mind. I got nothing. this is the formula, right? And what I need to do is I need to plug in values for that. So this is my a. This is my B, and this is my C. Now, I want to stress to you that A is only the number in front. It does not include the x squared. It's only the coefficient, all right? So it's only this number, not including the x and the x squared, right? So now all I have to do is just plug it into the equation, right? I have negative B. My B is a negative 80. So I need to be very careful with the negatives here, right? So negative times a negative 80 all over 2 times my A. My A is a negative 4. Wow, there's a lot of negatives in this one I got to be careful with, right? So that becomes... So over here, I'm going to just add... sorry, this is going to become a positive 80. I don't even need that positive, so I'm just going to write 80. So I have 80 over 2 times a negative 4, which is a negative 8. So I now have 80 over negative 8, right? Which is going to really just be a negative 10. So what I have is I have x is equal to negative 10, because remember the equation is x equals negative 10. Now, you're going to be very tempted to write negative 10 and think that negative 10 is the answer. But remember, the axis of symmetry is a line. So because it's a line, I need an actual equation. So it must be x equals negative 10. If I just wrote negative 10, I've just given a value, but I have not given the equation of a line. So this would in fact be wrong. Make sure you have x equals negative 10 because it's the axis of symmetry. And so once again, if you're following the formula, you should end up getting x equals negative 10. That would be the answer, right? So okay, once again, with this one, it would be the same thing. Negative b over 2a is equal to x, right? And so this would be a negative times 12, right? Over 2 times my a value. There's no a value listed. So if there's none listed, it's just 1. So 2 times 1, right? Which is equal to negative 12. What is that? Negative 12 over 2, which is equal to negative 6. So my final equation is x is equal to negative 6, okay? Perfect. All right. Well, I think that's going to be it for the day. I'm going to talk about what you do for this one, just to talk about the steps. So the first steps would be I'd add the 91 to both sides. That's my first step, right? So that, you know what, let me just do it. R squared minus 4r is equal to 98, right? So now that I have that here, so that's my first step in completing the square. The second step would be to take this b, the negative 4, and divide it by 2, okay? So that'd be the next step. That would give me negative 2. The third step, so once again, the first step was to move over the 91 to make space here. The second step was take that negative 4, the b value, divide it by 2, I get negative 2. The third step is to take that negative 2 and square it, right? Remember, to put your value, this value in parentheses before you square it, and I should get a positive 4 here. So that 4 here is going to be added to both sides. So I'm going to add 4 here, and I'm going to add 4 here. So that's my fourth step. After I've squared it, I add 4 to both sides, all right? The fifth step to this is to turn this now into r minus 2. Whoops. I think hiccuped on me there. R minus 2 squared, which I got that minus 2 from right here. This becomes what completes that square, okay? And that's equal to whatever's on this side, which is 102. Then once again, you take the square root, and I think you can do it from here, right? But I just wanted to show you that, once again, the steps. The first step, adding that 91 to both sides to clear up that space. The second step, taking this number, dividing it by 2 to get the negative 2 here. Third step, taking that negative 2 and squaring it to get this. The fourth step, adding that 4 to both sides, and so on and so forth. But anyway, I hope you had a great time. I really do. I hope you had a wonderful time. You know what? At this point, you can stop watching the video. This will be good. It'll count for your test incentive. I'm going to do one more thing, though. I'm actually going to work through maybe one. Never. Yeah, I'm just going to talk about one more problem. But if you want to stop there, that's fine, all right? I'm going to talk about this express in simplest radical form. If you just wanted to do this, what you would do is you take and just multiply these together. What's 2 times 7? 2 times 7 is 14. So it's just the square root of 14. All right, now the square root of, yeah, that's it, square root of 14. This one here would be 3 times 15, which is going to be the square root of 45. Ooh, they got tricky over here, though. So this one's the square root of 45. This one's square root of 14. So square root of 14 actually doesn't simplify anymore. Like that's it. Like, you know, there's no perfect square that goes into it, so it's just the square root of 14. But this one here, the square root of 45, is actually the square root of 9, right? And the square root of 5. So this actually becomes 3 square roots of 5. So this one actually can simplify, this one cannot. But anyway, hopefully you're having a great day. I thank you once again for being amazing and doing the work that you need to do to be successful. I hope that this was helpful to you. If in fact this is helpful to you, hey, it's always nice to see you doing well. So it makes us happy when you're doing well. So anyway, thank you once again for your time. Thanks for being the great student that you are, and I look forward to seeing you again another time. Don't forget, this is the beginning of your studies, right? Study the rest of the study sheet so that you are good on that front, and I wish you the very best. Have a wonderful, wonderful, wonderful test.